Dear all, could you really be careful when using this formula, particularly with the understanding of this part here, showing the values of x for which this expansion is valid, okay? So you have x to the power of 0, x to the power of 1, x to the power of 2, and so on and so forth for these values of x here. Now, please notice it's only valid because when this is being raised to higher and higher and higher powers as you go on, each term that you add on is going to get smaller and smaller and smaller as long as it's less than 1. Okay, if it's equal to 1, each of the terms can actually get progressively larger and larger and larger. And if it's greater than 1 and you square something or raise to high power, it's absolutely going to get much larger. So each term you add on is going to be much larger. So when you add these things on, it will just add to a bigger and bigger value heading towards infinity. But the nice thing about this, which I'm not seeing in much of your homework, is appreciation of this. Okay, values for x for which expansion is valid are ones for which you're going to have a tendency or convergence on a particular value. So you're adding on something which is going to get much smaller. So that's why typically you only need the first 3 or 4 terms or whatever it may be, because no matter what you add on, you're going to add something on which is progressively smaller and smaller. They don't have an effect to the actual total. So it might, for instance, converge onto 3, for instance, and that would be approximation for whatever expansion you're doing. But please make sure you're aware of this and recognize it can be written as this as well. But a lot of your homeworks, I'm not seeing much appreciation of this idea.